Let us now complete the final part of chapter 2 on polynomials. In the last few videos, we have been discussing about the algebraic identities. We have seen 8 different identities, and then in the previous video we also developed a new identity, which is the 9th identity, and we saw several examples of how to use the identities to solve algebraic expressions or to evaluate some calculation, and also to factorize some expressions, right? So we will continue with that discussion, and we will do the last few problems that are given in the exercise 2.4. So we have 4 problems remaining, and let us start with the first of the remaining problems. We are given that if x plus y plus z equals 0, show that x cubed plus y cubed plus z cubed equals 3xyz. Now this can be solved in 2 different ways. Let me show you the first solution, wherein we are going to use the identity number 8. So let me write the identity number 8. So we now have written down identity number 8, which is giving that x cubed plus y cubed plus z cubed minus 3xyz is equal to x plus y plus z multiplied with x squared plus y squared plus z squared minus xy minus yz minus xz. Now, since we are given that x plus y plus z equals 0, so that means we are given that this first term here is 0. So that means 0 multiplied with anything is 0. So the right hand side completely becomes 0. Okay, so which is equal to 0 since we are given that x plus y plus z equals 0. So in that case, what happens now is the left hand side becomes equal to 0. So the LHS is x cubed plus y cubed plus z cubed minus 3xyz equals 0. So therefore we can now move the 3xyz to the other side of the equal sign. So we will have therefore x cubed plus y cubed plus z cubed equals 3xyz. So hence we have proved that when x plus y plus z equals 0, x cubed plus y cubed plus z cubed equals 3xyz, which is what we have to show, and it has been shown in a very simple way by using the identity number 8. Okay, that's one way of doing it. The other way of doing that is by using the direct relationship of x plus y plus z, what is given to us. Okay, so another method I will write out here. So we are given x plus y plus z equals 0. So we can write this as x plus y equals minus z. That means we have just moved the z to the other side of the equal sign. So we get x plus y equals minus z. And now we can cube the entire equation. So we can raise the entire equation to the power 3. So x plus y cubed equals minus z power 3. So so that way what will happen now is x plus y the whole cube. So what is the relationship for x plus y the whole cube? We know that x plus y the whole cube is equal to x cubed plus y cubed plus 3xy into x plus y. So this is the identity that we have for x plus y the whole cube, which is identity number 7, I believe. Okay, so it's identity number 6 that we have seen earlier. So x plus y the whole cube is given by this identity, and now in this we can substitute for x plus y. So we got x plus y as minus z, right? So in place of x plus y we can substitute minus z, so that will be x cubed. By the way, okay, the LHS is x plus y the whole cube, which is this term, equals minus z cube, right? So x plus y the whole cube is given by this, and that is equal to the right hand side, which is minus z cube is minus z cube. Okay, so we have the LHS given by this expansion for the identity, and the right hand side is minus z cube. So minus z the whole cube is simply minus z power 3, and now we can use this expression to simplify it. So we can now write x cube plus y cube. Let me write down. Okay, this x plus y is equal to minus z. How? Because we have shown it over here that x plus y is equal to minus z. So we can use that relationship and substitute in place of x plus y. So we will get x cube plus y cube plus 3xy into x plus y is minus z equals minus z cube. So now we have x cube plus y cube minus 3xyz equals minus z cube. So in the final step, what we can do now is we can move the z cube, the negative z cube, to the left hand side of the equal sign, and the minus 3xyz to the right hand side of the equal sign. So we will have x cube plus y cube plus z cube. So the minus z cube, when it moves to the other side, it becomes plus z cube, and the minus 3xyz, when it moves to the right hand side from the left, it becomes plus 3xyz. So now again we have shown that x cube plus y cube plus z cube equals 3xyz. Okay, this is the proof that we are asked to show, and hence we have proved that. Okay, so this is the second method. Okay, I'll write here method 2. Okay, so we could solve this problem either by using the identity for the x cube plus y cube plus z cube minus 3xyz, and then substituting 0 for x plus y plus z, and solving the equation will give us the relationship that we are looking for. Or we could have done it using this method as well. So either way is okay to be done, and we have shown the required expression that is asked to be proven given this condition x plus y plus z equals 0. Right, let's move on to the next question. Question number 14. We are asked to calculate these values, minus 12 cube plus 7 cube plus 5 cube. Now, without actually calculating the cube, so without calculating minus 12 cube or 7 cube or 5 cube, we have to evaluate this expression, this equation, and find the value for this expression. So it is having the form of x cube plus y cube plus z cube, right? And if you look at this, x is minus 12, y is 7, and z is 5. So x is minus 12, y is 7, and z is 5. And what we notice here is that the sum x plus y plus z, which is minus 12 plus 7 plus 5 equals 0. So since we have x plus y plus z equals 0, again using our identity number 8, so let me rewrite the identity number 8 from our previous page. So identity number 8 is given by this expression. So we'll use this, and in this we are getting that x plus y plus z equals 0. So let's rewrite this expression first. So we have this identity number 8, which is x cube plus y cube plus z cube minus 3xyz equals x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Now, since we find that x plus y plus z in this case turns out to be 0, so the right hand side of this expression will be 0. So therefore what will happen is, since x plus y plus z equals 0, we will have x cube plus y cube plus z cube equals 3xyz, which is exactly what we proved in the previous case. Okay, in the previous problem, we showed that when x plus y plus z equals 0, then x cubed plus y cubed plus z cubed will be equal to 3xyz, which is exactly what we are getting here. So now we are asked to evaluate x cubed plus y cubed plus z cubed, so which will be the same as 3 times xyz. So in our case, this is 3 times x is minus 12, y is 7, and z is 5. So this will be equal to 7 into 5 is 35, and 3 into 12 is 36. So it's minus 36 into 35, which is equal to minus 1260. Okay, so basically we have now used the identity number 8 to calculate the sum of these cubes now without actually computing the individual cubes. Okay, so we use the relationship that x plus y plus z is 0. So clearly from these given numbers for x, y, and z, we see that x plus y plus z is 0, and therefore we got this relationship that x cubed plus y cubed plus z cubed equals 3xyz, and we are asked to find x cubed plus y cubed plus z cubed, so which is the same as calculating 3 times xyz, and we have obtained our answer without calculating the cubes of these numbers. Okay, so the second problem is something very similar. So again here we will notice that we have to calculate x cubed plus y cubed plus z cubed. So in this case also we notice x is 28, y is negative 15, that's minus 15, and z is minus 13. And we see that x plus y plus z is 28 minus 15 minus 13, which is equal to 0. So now, since x plus y plus z equals 0, we get our relationship x cubed plus y cubed plus z cubed equals 3xyz. So we have, in place of x cubed, we have 28 cubed, plus in place of y cubed it is minus 15 cubed, and in place of z cubed is minus 13 cubed, and that will be equal to 3 times xyz. So 3 into 28, that's 3 into 28 into minus 15 into minus 13. So when we perform this product, we will get our answer, which turns out to be equal to 16,380. Okay, so we get 16380 as the answer to the sum of these cubes, and we have evaluated this sum of these cubes without actually computing the individual cubes of these numbers. Okay, so we use the identity to compute the sum of the cubes of these three numbers. Alright, so let's move on to the next problem. Question number 15. We are given expressions for the areas of the rectangles, and we are asked to find the expressions for the length and breadth of those rectangles. So this expression corresponds to the area of a rectangle. So let's write the formula for area. Area is length into breadth, and that is given as 25a square minus 35a plus 12. And we are asked to find what is the length and what is the breadth. Basically, what this problem is asking us to do is to find the factors of this quadratic polynomial, and the factors that we get. So because it's a quadratic polynomial, we will have two factors. So we could go about calculating the factors of this polynomial by any of the methods, using the factor theorem or by splitting the middle term as well. So once we get the two factors of it, one of the factor will correspond to the length of the rectangle and the other factor will correspond to the breadth of the rectangle. So let us do the factorization by splitting the middle term. So we have our expression 25a square 25a square minus 35a plus 12 here. Okay, so that's plus 12. So we need to choose two numbers. That means we need to split the middle term in such a way that the sum of the two numbers is minus 35 and the product is 25 into 12. So 25 into 12 is 300. So we need to choose two numbers such that the product is 300 and the sum of those two numbers is minus 35. So what could be the two numbers that we can choose such that their product is plus 300 and their sum is minus 35? The two numbers can be 20 and 15. So you can choose 20 as one number. So one of the numbers is 20, the other is 15. And we will have 20 into 15 will give us 300. And 20 plus 15 is plus 35, but we need minus 35. So we'll put a minus in front of both the numbers. So now we have minus 20 into minus 15 is plus 300. So minus into minus becomes plus, and 20 into 15 is 300. And when we add these, we get minus 35. So we can split the middle term using these two numbers, minus 20 and minus 15. So we will have 25a square minus 20a minus 15a plus 12. So now we can take some common term here. So for the first two terms, we can take a common factor outside. Well, that could be 5a is our common factor. So 5a into 5a will give us 25a square minus, we can have 4. So 5a into 4 will be 20a. So we put a minus, and 5a into 4 is 20a. And as usual, we will replicate this 5a minus 4 and then find the term or the number with which we multiply this term in the bracket. It should give us the second half of this expression. So that would be minus 3. So minus 3 into plus 5a will be minus 15a, and minus 3 into minus 4 will give us plus 12. So now we can take the 5a minus 4 as a common factor, and then we have 5a minus 3 as the second term. So the given polynomial is split into its factors, 5a minus 4 and 5a minus 3. So this is the area. This is the expression for the area of the rectangle, and the area of the rectangle is a product of these two factors. So one of the factors will therefore correspond to the length, and the other will correspond to the breadth. Now, which is the length and which is the breadth, that is something we have to figure out. That depends on the value of a, but generally one of them we can say it is the length and the other is breadth. So the possible expressions for length and breadth are expressions for length and breadth are 5a minus 4 and 5a minus 3. So these will be our expressions for length and breadth. Again, when you read the question at first, it may seem vague as to what is being asked, but you have to think and understand the question very clearly. We are given the area and we are asked to find the length and breadth. Clearly, we know that the area of a rectangle is length into breadth, so we can factorize this expression for the area into its factors, and one of the factors will correspond to the length, and the other factor will correspond to the breadth. So basically, this question is indirectly asking us to factorize this particular expression that is given here. Okay, we have the second expression here. Again, this is the expression given for the area, and we have to find the length and breadth expressions. So let's write down again. Area equals length into breadth, and that is given to be 35 y square plus 13y minus 12. And again, basically what we have to do is simply factorize this expression and find its two factors. One of the factor will correspond to the length and the other will correspond to the breadth of the rectangle. So we need to factorize 35y square plus 13y minus 12. So we need to split the middle term. So we are going to again use the method of splitting the middle term. So to split the middle term, we have to choose two numbers such that their sum is 13 and their product is 35 into 12. So that's 350 plus 70, so that's minus 420. Okay, minus 420. So we need two numbers whose product is minus 420 and their sum is 13. Minus 420 because 35 into minus 12 is minus 420 and the middle term is 13, so we need the sum to be 13. So the two numbers that we can choose whose product is minus 420 and sum is 13 are going to be 28 and 15. Clearly the difference between 28 and 15 is 13, and we need to put a minus sign in front of one of these numbers so that the product becomes negative. So we can put the minus either in front of 28 or in front of 15. So if we put it in front of 28, the product will be all right, minus 420, but minus 28 plus 15 will become minus 13. We want a plus 13, so the correct choice of numbers will be plus 28 and minus 15. So now we will have the required combination that we need. So 28 into minus 15 is minus 420 and 28 minus 15 is plus 13 as we require. So we can split the middle term now using these two numbers, 28 and minus 15. So we can write 35y square plus 28y minus 15y minus 12. So now we can take some common term. What could be a common term for the first two terms, for 35y square and 28y? Between 35 and 28, the common number is 7. So we can take 7 and we can also have a y outside. So 7y. So inside the bracket we will have 5y. So 7y into 5y is 35y square, and we have a plus, and then it's 28y. So 7 into 4 is 28 and we have a y outside. So 7y into 4 is 28y, and we will replicate this term in the brackets. That's 5y plus 4, and then we'll figure out what should be multiplied outside to get the remaining terms, which is minus 15y minus 12. So we have 5y as the first term in the bracket, so we multiply 5y with minus 3. That should give us minus 15y. So minus 3 into 5 is minus 15, and then we also have y, so it's minus 15y, and minus 3 into plus 4 is minus 12. So now we can take the 5y plus 4 as a common factor, and then we have 7y minus 3 as the second factor. So now the possible expressions for length and breadth are 5y plus 4 and 7y minus 3. And that's because our expression for the area is a product of these two terms. One of the term will be corresponding to the length and the other will be corresponding to the breadth. So the product of length and breadth gives us the area of the rectangle. So the length and breadth are going to have the expressions 5y plus 4 and 7y minus 3. Okay, so basically this is an indirect way of asking to factorize these polynomials. Okay, let's move on to the final question of this exercise, which is again something similar. We are given expressions for the volumes of cuboids, and we are asked to find the possible dimensions of the cuboids. So again, for a cuboid, the formula for the volume is length into breadth into height. So we need to factorize these volume expressions as a product of three terms. And one of the terms, once we have the product of three terms, one of the term will correspond to the length, the second term will correspond to the breadth, and the third term will correspond to the height of the cuboid. So the volume formula for the cuboid, volume equals length into breadth into height, and that is given to be equal to 3x square minus 12x. And again, we don't need to use any specific technique here. We can just take a common factor out and simplify this, and we'll get the factors of this particular expression. So we can write 3x square minus 12x by taking a common factor as 3x. So 3x into x minus 12. So 3x into x is 3x square, not x minus 12. Let me correct that. Into x minus 4, that is. Okay, we need 4 here. So now we have 3x into x is 3x square minus 3x into 4 is 12x, so minus 12x. So now we have this expression for the volume in terms of the product of 3 terms. So this is it's like 3 into x minus 4, that is 3. I'll put the into with a red pen. So 3 into x into x minus 4. The final term is x minus 4. So now one of these terms is corresponding to the length. So we have it as length into breadth into height. So 3 into x minus 4. So we can say length is 3, the breadth is x, and the height is x minus 4. So we can call this as length, the second term as breadth, and the third term as height. So the possible expressions for the dimensions are possible expressions for the dimensions of the cuboid are 3x and x minus 4. So these are the expressions for the 3 dimensions of the cuboid, whose volume is given by this expression 3x square minus 12x. Okay, coming to the final expression, final problem. It is something similar. Again, we are given the volume, expression for the volume, and we are asked to find the dimensions of the cuboid. So since volume is the product of 3 terms, length, breadth, and height, so we need to factorize this into a product of 3 terms, and each of those 3 terms will represent or denote the length, breadth, and height respectively. So again, volume equals length into breadth into height equals 12ky square plus 8ky minus 20k. So now we can factorize 12ky square plus 8ky minus 20k. So 12ky square plus 8ky minus 20k. So what could be a common term that can be taken out in this expression? We can take 4y and k outside the bracket, and inside we can have if we take 4y and k, we will, okay, let me write it as 4ky rather than yk, since we have used a ky combination. So 4ky, we need 12ky square, so that will be 3y. So if we multiply this 4ky with 3y, so 4 into 3 is 12, k and y into y is y square. So we get 12ky square, and then we have 4ky. No, we can't take the y outside actually, because the last term does not have a k. So let me make that correction here. So we can take only the 4k as the common factor. So when we take 4k as the common factor, we will have 3y square inside, so 4k into 3y square. So 4k into 3y square is 12ky square, and plus 8ky, so that will be plus 2y. So we'll have 4k plus into 2y, so 4 into 2 is 8, k into y is ky, so 8ky. And then we'll have minus 20k. So because we need minus 20k, we can put 4k into minus 5 will be minus 20k. So we have 4k into 3y square plus 2y minus 5. So now what we can do is we can factorize the term inside the bracket. That is a quadratic polynomial. So we can factorize this further. So we can write 3y square plus 2y minus 5 can be factorized. So I'm going to factorize that and then substitute it in the whole expression. So we can again use the method of splitting the middle term. So we need to find two numbers such that their sum is 2 and their product is minus 15. Minus 15 because 3 into minus 5 is minus 15. So the product has to be equal to A into C. So A is 3 and C is minus 5. So 3 into minus 5 is minus 15. And the sum has to be 2. So we need to find two numbers whose sum is 2 and product is minus 15. So we can choose 5 and 3. And if we put a minus in front of 3 now, so you will have 5 into minus 3 is minus 15. And 5 minus 3 is plus 2. So we can split the middle term using these two numbers. So we will have 3y square minus 3y, I'm writing the 3 first, plus 5y minus 5. Okay, so I've just rearranged the terms here because we can take the 3 as a common factor outside if we keep them together. So now we can take 3y as a common factor and it will be y minus 1, and we replicate the y minus 1 here and find out that plus 5 is the term that multiplies the term in the bracket. So plus 5 into y is plus 5y, and plus 5 into minus 1 is minus 5. So now we can take the y minus 1 as a common factor, and we have 3y plus 5 as the other term. So now we can rewrite our entire expression as... So now we can write our expression for the volume, which is 12ky square plus 8ky minus 20k as 4k into y minus 1 into 3y plus 5. So we now have it as the product of three terms. The first term is 4k, the second term is y minus 1, and the third term is 3y plus 5. So each of these terms would correspond to one of the dimensions of the cuboid. So we can we can say that the dimensions are dimensions of cuboid are 4k is one of the dimensions, y minus 1 is another dimension, and the third dimension is 3y plus 5. Okay, so now we have seen all the different ways in which we can use the algebraic identities to solve algebraic expressions, to evaluate or compute certain calculations, and also to factorize algebraic expressions. And we have seen a lot of examples, including the worked out examples and problems from the exercise, and it requires some practice in order to have some clear understanding of how to proceed with this. So generally what we have to do is you have to remember the identities and try to represent the given expressions in a form that resembles one of the identities, and then simplify it based on that particular representation. And that way you will be able to simplify or evaluate the given expression based on the identity. But to identify which is the correct identity that matches with the given expression, it requires a little bit of practice. So it is imperative that you practice the problems, including the exercise problems and the example problems in the text, and that is the only way you will be able to correctly solve the problems in an exam setting. Okay, we'll stop here for now. This brings us to the end of chapter 2, and we will continue further with the next chapter in our next video.